Good evening, everyone. Very good evening. My name is Vishwadeep here, and quickly just confirm that you are able to hear me. I am audible. Voice is clear. The PPT is visible. Please confirm in the chat box so that we can start the session. So as soon as possible, if you'll confirm, that will be good for session to start. Fine. Okay. So today, what is the good evening, KD? Very, very good evening. So today's the agenda of the class is this that we are going to start a chapter CPU. So we are going to discuss the chapter CPU, how it works. Then in that we are going to talk about CPU's cycle. What is the CPU cycle? Then we are going to talk about CPI, cycles per instruction. Then we are going to calculate execution time required by CPU to execute some number of instructions. And then we are going to discuss the performance of CPU measured by a metric called as MIPS, million instructions per second. Okay, so if you are already here, so first of all, what you need to do here is please like the video and share the link with your friends so that they can join the session live. Yes, that's your duty per day. If you are listening the live lecture here, then it's a regular duty you need to follow, just because it's our responsibility that we are providing you very high quality education for free. So for exchange, what we want from your end is like the video and subscribe the channels for future references so that you can get all those future videos, like if any new video comes or any new lecture comes, whatever the lecture we are going to have, you will be able to get all this information. And then share the videos with your friends so that maximum people can be the part of our family. Yes, our family, you, me, we are a family and we want to achieve something together. What? Your rank, your IIT's admission, MIT's IIC's admission, and your PSU admission, or whatever the target you are having. So that is the target we both are trying to achieve through this particular journey. So it's really simple thing we need to do is I will provide you higher quality education. You provide me some likes, some shares, some subscriptions. Okay, let's start the following things. My name is Vishwadeep. If you all know me, that's well and good. If you don't know, then my current rank is 29th. In just 1.5 months I have achieved it in the Unacademy. So this rank is among all the educators of GATE and EAC, among all the branches. Right now, this you can see there are so many dedications, so many followers, so many watch minutes, and other thing. If you want to be the part of that revolution which we started on Unacademy from 13th July, what revolution we started on 13th July is a batch of computer science in which we are having a team of top educators. Yes, we are having a team of top educators, and that team will make your dream come true. So I'm not saying that I will alone will help you. No, no, no. My team and my entire team, our team will help you to get your rank, your target, your dream come true. Right? So if you want to get the Unacademy Plus ka subscription, you can take it with using this code VDEEP10. It's a deep trust you are going to put on my team, not on me, buddy, my team. Always I'm telling you the success cannot be, thank you so much, KD. The success cannot be, obtained using only one person here, with help of only one person here. I cannot teach you all the courses. Of course, I cannot help you with all the courses with perfection, of course. So my team, the top educators team, will help you in this particular case. So if you are having any query, question or doubt or something, that if suppose sir, how to prepare these courses for free and how to prepare these courses, I want to prepare only these courses, then how you will resolve all those problems? Okay, कोई प्रॉब्लम नहीं है, ये है ना, कॉन्टेक्ट मी ऑन दिस नंबर 7899312226. दैट्स माय पर्सनल नंबर. कॉन्टेक्ट मी and you will be able to hear all the answers. Fine. Doesn't matter if you want to get the plus subscription or not, just contact me so that I can help you with your preparation plan. My name is Vishwadeep. As I already told you, this is my profile. Gate in computer science multiple times. This is my final year rank, third year rank 682 in engineering itself. Apart from that, multiple times I have given the exam, rank 119, 440, this 682 and multiple other ranks. Two MTechs, one is from IIC Bangalore, another MTech from BITS Pillani in the data science, hence study wise it's fine. This is my overall experience. These are the courses I am teaching. This computer organization I have started here also. I have started on Unacademy Plus also. If you can visit my profile on Unacademy, this is my profile VD_Goti. If you will search my name also, you can fetch my profile with this photograph. You just see the dedication. Here the dedications are, you just see what students are feeling about my course. Fine. So if you want to join Unacademy Plus, then you can use this code VDEEP10, or else you can contact me on 7899312226. Right? Okay, these are the benefits. Lots of benefits are there. I will explain you what are the benefits of Unacademy Plus. Just drop me a message also on WhatsApp, no problem. Okay, fine. Let's go further. How to take the subscription? You guys are techie, so you know how to do that. But if you are very serious about your preparation, if you are very sincere about your preparation, then don't take much time. Just put this particular button touched and go for the subscription. These are the different subscriptions you can take based on your courses and preparation plan that I can help you with. कि कितना plan कब कैसे बनाना है. Use this code. Remember the code VDEEP10 to get the discount, and this 22,500 for 1 year is just 60 rupees per day, which is not too much, buddy. And this is just 40 rupees per day if you are in third year, and if you want to prepare for 2 years, it's very less, not too much. Good evening everyone, good evening. I want everybody to like the video, subscribe the channel, so that for all the future videos you can get the notifications. घंटी बजा दो जल्दी से और जल्दी से. Now before I start this particular CPU chapter, you need to tell me that if you are able to listen me properly or not. If you are able to listen me properly and if you are ready to study, then please type down yes, no, ready, not ready in the comment box, so that I can interact with you during the classroom. See, it's already in the YouTube, we can understand it's not too good interaction we can have, but still I will try to connect with you all if you are really learning here. So type down in the comment box कि आप सीख रहे हैं या नहीं. If you are learning, please type down so that I can understand if you are learning or not, if you are connected or not. Type down in the comment box. जल्दी से type करो भाई, जल्दी से type करो. Yes, okay, fine. Okay, that's good. Fine. So let's start the first topic of the day, which is CPU, the definition. If somebody asks you what is the CPU, don't say central processing unit. अरे ये तो full form है भाई. सेंट्रल प्रोसेसिंग यूनिट का डेफिनेशन बताने का है. व्हाट इज द डेफिनेशन? डेफिनेशन इज दिस: main component of computer system which performs operation and controls the system, that is your CPU. You can call it as like heart, brain, kidney, liver, everything of your computer system, right? So in the computer system, in the CPU, we need to see these three things. But before that, I will explain you very fine detail here. If you have attended my previous classes, you will be able to map this information. If not, then again I am repeating: CPU cannot perform one complete operation in one time. सीपीयू एक बार में पूरा ऑपरेशन नहीं परफॉर्म कर सकता. वन ऑपरेशन मीन्स लेट्स से आई एम सेइंग वन इंस्ट्रक्शन एग्जीक्यूशन, or if one operation, let's say I'm saying like instruction ka fetch, within the instruction also one operation may be instruction ka decode, one operation may be operand fetch. So these operations CPU cannot perform in single go, which means in the single time, in one time CPU cannot perform one operation. What CPU does, CPU breaks down those operations into small operations like this, and combination of such small operations will perform one operation complete, and that particular combination, these small operations are known as, आपको पता होगा, you might have known क्या होता है, micro operations. These are known as micro operations. So I can understand it like this way कि CPU can perform one micro operation at a time. Reason of this particular point you will understand tomorrow for sure. I will explain you with certain more details कि ऐसा होता क्यों है, why it happens. But today just remember one thing, CPU cannot perform one operation in one go, in one time. Hence CPU performs one instruction execution or one operation in small operations, and each operation is known as micro operation. Now listen, I can say that CPU can perform one micro operation in one time. How much time? Kitna time? And that particular how much time answer is CPU's cycle time. What is the answer? CPU's cycle time. So this CPU cycle, if I want to write the definition, what is this definition? That time in which CPU can perform one smallest operation. CPU can perform one smallest operation, and that what is that smallest operation, bhai? Jaldi batao, what is that smallest operation? That smallest operation is a micro operation. What is that? Micro operation. If you are sincerely learning here and you really want to learn more, then only one thing I can ask from your end is interact. Anytime if I ask that what is this, you need to type down in the comment box, and you need to say yes, no, understanding, not understanding, clear, not clear, every single time when I'm asking. If in this way you will be learning, you will be attending my classes, definitely I can tell you, you will learn a lot just because you will be engaged along with me. Fine. So if I'm saying CPU takes some time to perform one smallest operation, that is called as CPU ka cycle time. If CPU cycle time is this much t, then can you tell me what is the CPU ka clock rate? Is frequency, that with what rate CPU can perform the operations. So clock rate will be very simple, 1 by clock cycle time. Very simple. Right or wrong? Yes, of course, it's very simple. Yeah, very simple it is. Clock rate is nothing but 1 by time. Right? Next is what? CPI. CPI, full form of CPI आपको पता है क्या क्या होता है CPI का full form? In the starting of the lecture only I have told you, cycles per instruction. Cycles per instructions. Per instruction. Now what is this? Now what is this? CPI is what? Definition के वैसे आपको जरूरत लगेगी नहीं. You won't require definition. The word itself is a definition. As I already told you that an operation is performed in the small operation. One particular micro operation is performed in one cycle, which is one cycle ka time. Right? So one cycle, suppose 5 nanosecond, one cycle is 5 nanosecond, 5 nanosecond, 5 nanosecond. How many cycles you can see here for one operation? 3 cycles. So 3 cycles for one operation. Similarly, I am asking you how many such small cycles are required to execute one complete instruction in the CPU. Complete instruction execution, which means it requires operand fetch, it requires instruction fetch also, it requires decode also, it requires effective address calculation also, it requires operand fetch also, execution also, write back also, everything included. How many number of cycles required to execute one instruction is CPI. So this is number of cycles, it's not the time, okay, it's a number of cycles. So I'm writing the definition here. Definition is very simple: number of cycles, or I should write here CPU ka cycle, number of CPU cycles required to execute to execute एन इंस्ट्रक्शन. सो एक इंस्ट्रक्शन को एग्जीक्यूट करने के लिए कितना नंबर ऑफ साइकिल्स लगेगा, दैट इज योर सीपीआई. नाउ further I am saying very simple question to you. Suppose there is a CPU which is having 2 nanosecond as CPU cycle time. Assume 2 nanosecond CPU ka cycle time, and on an average every instruction takes 6 cycles to execute. Every instruction takes 6 number of cycles to execute, means CPI for that CPU, CPI for that computer system is 6, and every cycle time is how much? 2 nanoseconds. So one instruction execution time will be how much? One instruction execution time will be how much? Instruction takes 6 cycles. Each cycle time is 2 nanoseconds. Answer will be typed down. The answer will be 12 nanoseconds. 6 into 2. So CPI into CPU cycle time will give you what? One instruction ka execution time. So if I want to know execution time for one instruction, right? For one instruction, then it will be what? It will be very simple formula. You only can tell me. You don't have to remember this formula. याद नहीं रखना है formula. You will have to just understand the concept. Understand the concept. Formula automatically बनेगा. Formula automatically you will be able to create on spot. Yes. So one instruction execution is nothing but CPI into one cycle time. Very simple. Very simple. Yes. Now, if one instruction execution time is this much, can you tell me what will be the n instruction execution time? N number of instruction will be executed in how much time? कितना time लगेगा n number of instructions को execute करने के लिए? And my answer will be what? You only tell me. Yeah, type down answers. You need to type down the answer for n number of instructions. For n instructions, execution time will be how much? Answer will be equal to n into one instruction execution time, which is CPI into one cycle time. Simple. Very simple, right? Very simple. Now I am asking you very simple thing. Very simple thing. Now just listen, concentrate, and give me the answer. That are you able to understand this or not? Give me the answer. Or I am asking you a very simple question. Question is every type of instruction takes same CPI in CPU? Same CPI means same cycles for execution. Every type of instruction will take same CPI in the CPU or not? Your answer I want here. Okay, that's good. काफी सारे लोग interact कर रहे हैं. Your answer should be no. Every type of instructions execution is different. So one instruction can take 6 CPI. One instruction can take 8 CPI. One instruction can take 10 CPI. अब ऐसा vary क्यों हुआ? Why? Just because one instruction can take operand from register itself. So CPU के अंदर ही है, कम time लगेगा. One particular instruction can take operand from memory. So of course ज़्यादा time लगेगा. One operation may take more time in ALU. Yes. So different types of instructions may take different number of cycles in the CPU for execution. If that is the case, then can I write only CPI here? Nahi. What should I write here is CPI average. So this should not be the CPI, but it should be average CPI for one instruction. I guess आप समझ पाए होंगे कि why I am writing average here. Why? Just because every type of instruction will take different number of cycles for execution. So I will calculate average CPI on an average, let's say 8 cycles per instruction. Maybe some can take more, some can take less. Average itana. If you are able to understand till now, if it is clear till now, can we go forward? Just type down clear or not clear. Let's know, let me know if you are clear till now or not. So based on that, I can explain you further few things. Okay, so how exactly you are going to calculate this CPI average? For that, I am having very simple example in front of you. So consider computing the overall CPI for a machine A for which the following performance measure were recorded when executing a set of benchmark programs. Benchmark program is nothing but it's a program which we use for some testing purpose. That if this particular program is giving you this result, means yes, the result is better or not, you can measure it. So benchmark programs are like predefined kind of programs which you can use for the testing purpose. Okay, now see, suppose these are the different instruction categories, like an instruction which is having ALU operation, an instruction which is having load and store type, an instruction which is branch type, and other category. Suppose in a particular program you had 48% instructions of this ALU type, 10% of load store type, 39% of branch type, and 3% remaining of other type. Let's assume if number of total instruction, number of total instructions is equal to 200. 200 total instructions are there. 200 total instructions are there. Can you tell me, based on 48% ALU instructions, can you tell me how many number of instructions we can have in this particular program of only ALU type? Number of instructions of only ALU type. How many number of instructions we can have of ALU type if 48% instructions are ALU type instructions? Answer will be 48 into 200% or 48% of 200. 48% of 200 is what? 96. कितना आएगा? 96. Then 10% of 200 is 20. Then 39% of 200 कितना होगा? 78. And then 3% of 200 is 6. So these are the number of instructions of each type I have calculated. Now, suppose these are the number of cycles per instruction given. Like ALU type instruction takes only one cycle in CPU. It's just an assumption. Load and store type takes 3, branch type 4, other type 5. Tell me one thing. 96 instruction you have executed. Each instruction taken one cycle per instruction. One cycle, one instruction. Then for 96 instructions, how many cycles required? कितनी cycle की जरूरत लगेगी for 96 instruction? You only calculate the answer. Here, you only calculate the answer. So cycles. Oh, line को छोड़ो. So cycles for 96 instructions will be how many? Total number of cycles will be 96 into 1, 96. Similarly, how many number of cycles for load and store? Each is taking 20 total instructions. Answer is 60. Similarly, branch type instructions, 78 instructions are there and 4 such branch instruction. Each branch instruction is taking cycles. How much? 242. Okay, my mistake, not 242. 428 29 312 it should be. 312, sorry, my bad. 312. After that, others 5 cycles each instruction, total 6 instruction, total 30 cycles. Fine. Now tell me, total number of cycles will be how many? Total number of cycles will be how many to execute all the 200 instructions? Total cycles, can you calculate? Total cycles, can you calculate? 8. 498. 498 number of cycles I am getting. Can you confirm it? Can you confirm it? 498 is correct or not? So 498 number of cycles are required to execute 200 number of instructions. Now, if that is the case, then can you tell me what is the average CPI for previous calculations? CPI average will be equal to total number of cycles 498 divided by total number of instructions 200. So for 200 number of instructions 498 cycles are needed. Hence for each instruction on an average, how many number of cycles are needed? Answer will be, you only tell me how much it is. 2.49 is your CPI average based on the given metric or given information. It's not divided by 4. It is not divided by 4 KD. It's not per category we are calculating. It's per instruction we are calculating. Total 200 instructions hai bhaiya. 200 instructions are there and 200 instruction for one instruction I am calculating. What is the average cycle? That is why that answer is. It's fine if you are able to manage for understanding. So if suppose I want to write a basic a formula which is a general formula, then how I am calculating CPI average? I am taking multiplication of two things. For each type instruction, I am taking its number, total number of instruction of that type, and total cycles for that type instruction. And multiplication of that, I am taking this and this and this and this, and at the end summation. At the end summation, right? Fine. So exactly how CPI average I am calculating is this, that first of all I am having the number of instruction of a type instruction I into its CPI of type instruction I, and then this multiplication I am going to add for I equals to 1 to k. And what is k? K is total types of instructions I am having. Suppose 4 types of instruction I am having or 5 types of instruction I am having, like this, right? Okay, divide by what? Divide by what? इसको भाग देंगे किससे? किस चीज से भाग देंगे भैया? टोटल नंबर ऑफ इंस्ट्रक्शन. सो हाउ यू विल कैलकुलेट टोटल नंबर ऑफ इंस्ट्रक्शन? सपोज आई एम हैविंग वन टाइप इंस्ट्रक्शन इज ni, so I am having another summation here equals to k of ni. And what is these ni and CPI? Ni is number of instructions of type I, right? What is CPI? CPI for instruction type I. And what is K? Different types of instructions. Types of instructions. Fine. So if you are clear till now, write down in the comment box that if you are understanding or not. Hence, we can go for the next topic, which is MIPS. Right. So here I should write down a statement that CPU's performance is given by this MIPS. We measure CPU ka performance by this MIPS, and what is the full form of MIPS? Full form of MIPS is this: million instructions per second. See, it's very simple thing here. It's very simple thing. You measure the speed of your internet, which is the performance of your internet connection, right? Ki how fast your internet connection is, how you calculate it, how many number of bytes or kilobytes or megabytes your internet can or your connection can download for you, right? So why we give the answer in the kilobyte or megabyte? Why don't we give it in the bytes directly, that 1 lakh bytes per second it is transferring, or maybe 10 lakh bytes per second it is transferring? You know why? Just because that 10 lakh number of zeros are so many, the number is too large, so we convert that into kilo or mega or giga like this. होता है ना ऐसा? Do it. The same thing. CPU's performance is measured by that how many number of instructions it can execute in 1 second. Per second, how many number of instruction CPU can execute. Now what happens in that case? If I am calculating that number, that how many number of instructions CPU can execute in 1 second, that number is too large. In the lakhs, 20 lakh, 30 lakh, 40 lakh, crore bhi ho sakta hai. It can be 1 crore, it can be more than 1 crore. So what scientists have thought, let's convert this number into millions so that I don't have to write a larger number, a bigger number. So they have converted that number of instructions per second into million number of instructions per second. So instead of writing, let's say 20 lakhs, 20 and so many number of zeros, they have written it like this way, that 2 million per instructions. So number will be smaller. Fine, calculation आसान हो जाएगा, storage आसान हो जाएगा, and communication will be easy. That's why they have added this million word. Now I am asking you simple question. If suppose, okay, let me write down. आपको थोड़ा सा easy रहेगा. Suppose a CPU takes some t seconds time to execute n number of instructions. That I can calculate. Can I? Yes. That in to execute n number of instructions, how much time is required by CPU? That I can calculate. How? अरे ये है ना formula. Execution time is this much. N into average CPI into one cycle time. With that formula, I can calculate execution time for n number of instructions. If n number of instruction execution time is t seconds, can you only tell me number of instructions executed in 1 second will be how many? Number of instructions executed in 1 second is how many? In 1 second, number of instructions executed will be equal to n divided by t. Are you agree with me? Are you agree with me on this or not? And my unit will be number of instructions per second. आर यू एग्री विद मी और नॉट? इट्स वेरी सिंपल यार, बहुत आसान है, ये तो बच्चों वाला काम है, 8th क्लास में पढ़ते थे ये सब। 8th क्लास में, यस, वी वर स्टडीइंग ऑल दीज इन 8th क्लास। नाउ वी आर यूजिंग द सेम कंसेप्ट, राइट? मैथमेटिक्स थोड़ी बदलता है, मैथमेटिक्स डजंट change. So if number of instructions executed in 1 second is n by t, the same thing I am writing downside, same thing, right? So if I am calculating number of instructions executed in 1 second, then what is n? Number of instructions which we have executed, divide by total execution का time. Are you fine with this formula? If I am writing this same thing n and t, I have written the formula like this way. I am going little slow so that you can understand every single small concept also. If you want, I can increase the speed also. I am going slow क्योंकि आपको समझ में आनी चाहिए चीजें. If you will understand, you will remember for lifelong. Lifelong means up to the gate exam at least, whether it is 21 or 22, whatever. Fine. So number of instructions executed in 1 second is this. Number of instructions divided by total execution time. Suppose this number is 12 lakhs, or suppose this number is 20 lakhs. If I want to convert this number 20 lakhs into millions, ki how many millions in 20 lakhs? So what should I do to convert number into million? I will have to divide the number by 10 to the power 6. अब ये क्यों है? सिंपल सी बात है यार, 1000 में आते हैं 10 to the power 3, मिलियन में आते हैं 10 to the power 6. That is very simple. So you need to divide this number of instructions executed in 1 second by 10 to the power 6 to make it as number of, or how many million number of instructions supported or executed by the system in 1 second. So if I want to go from here to MIPS, then it will be very simple. MIPS will be equal to number of instructions divided by total execution time. टोटल लिख देना दो, नहीं तो बोलोगे सर यहाँ टोटल लिखा यहाँ नहीं लिखा, तो फिर कौन सा एग्जीक्यूशन टाइम लें? कंफ्यूजन है सर. Execution time into 10 to the power 6. So I have divided the whole quantity by 10 to the power 6. Hence the number becomes MIPS. Okay, fine. Now, execution time का formula है हमारे पास. What is that? What is that? N into CPI average into 1 cycle time. N is number of instructions into CPI average into 1 cycle time. So let's put it together. Okay, so I am having a formula for execution time. I know that execution time is equal to like this only we spoken in our school time, is equal to N into CPI average into 1 cycle time. अच्छा, एक क्वेश्चन पूछूं मैं आपसे. हाउ मेनी ऑफ यू आर फ्रॉम अ वेरी ऑर्डिनरी engineering college? How many of you are from very ordinary engineering college, not from very high-fi, very high-rank college? How many of you? It's okay. I am also. I have studied my BTech in very, very ordinary college. That was very, very ordinary. It is in Madhya Pradesh, Ujjain, called as Mahakal Institute of Technology. नाम short form में MIT है, but MIT is Mahakal Institute of Technology. It's not very good, but it is not so bad also. They have supported me quite well for my preparation. I'm just asking you why, just because there are so many students who are having doubts ki sir, we are from ordinary college, can we get the best rank or not? So I just want to know कि you are from normal college or which college, doesn't matter yaar. I could get rank 19, yes, all India rank 19 during my final year itself. Yeah, my faculty has helped me a lot. He has taught all the courses quite brilliantly. My teacher have supported me a lot, but still, from normal college to the highest level college, India's best college, IISc Bangalore. So if you are really having some kind of doubt that I cannot do or something, no doubt at all. Just prepare to the maximum efficiency, maximum productivity, and you will be having the best result in your hand. So execution time is this, then MIPS formula will change now. What I am doing is MIPS is equal to number of instructions n divided by number of instructions n into CPI average into cycle time n to n cancel into 10 to the power 6 also will be having here. So answer will be 1 divided by CPI average into cycle time into 10 to the power 6. So if somebody asks you what is the formula for MIPS, you can throw this formula easily in front of that fellow, right? Okay, fine. One more thing I'm having here. It's not a big surprise, Ray. You know that, Ray. You know that. You know what is the relation in clock rate and the cycle time? Here, clock rate is equal to 1 divided by cycle time. So if I want to know what is the clock rate, it is just the inverse of clock cycle time. So if I want to write instead of clock cycle time here clock rate, then my formula, another formula for MIPS will become what? Another formula for MIPS will become what? Will become clock rate divided by CPI average into 10 to the power 6. That is another formula, एक और formula. याद रखना है? अरे नहीं, you don't have to remember the formulas. You need to understand the concept. Formula will automatically arrive. Yes, you need to understand the concept. Formula will automatically arrive. Fine. So if you are done with this, if you are fine with this particular thing, then I want to tell you one thing, which, okay, before this question itself, that MIPS is not a good metric to calculate the performance of CPU. See, previously I told I am calculating performance of CPU by MIPS, but I am saying it's not a good metric. It is not a good metric. You know why? Okay, I am writing a statement. MIPS may provide false result in comparison of two processors. Or I should write, instead of in, I should write for. Okay, here I am having very beautiful example from our real world. It's my technique to teach you every time. Very good evening. Very good evening. It's my technique to teach you every single thing, every complex thing with some basic regular life examples, so that you can remember the concept for the longer time. If you will go along with me in entire course, you will find every say other topic you will be having, in which I will explain you the topic using some real world example. So here also I am having a real world example. Listen, you will enjoy. Suppose you and your friend has taken or has having a bet. You both are having the bet. What bet? Bet is who will solve more number of questions in 1 hour. Let's have a bet who will solve more number of questions in 1 hour. So you have actually challenged your friends. So you started preparing one day when the challenge could happen. You got to that particular place where the challenge can happen. Now you started solving the question. And You are solving the gate questions, gate level question you are solving of computer organization. In 1 hour, you could solve 12 questions. You could solve 12 number of questions in 1 hour. Now your friend was solving the questions of type this: 2 plus 3 is what? 6 plus 9 is what? 9 minus 2 is what? 5 plus 5 is what? Such kind of questions your friend was solving, and he could solve 100 questions in 1 hour. So you were able to solve only 12 questions in 1 hour. So your rate, your performance is what? 12 questions per hour. Your friend was able to solve 100 questions in an hour, so his rate is what? 100 questions per hour. Now you tell me, if I am comparing two friends, which number is larger? 100 questions per hour is larger. Your 12 questions per hour is smaller. So can you say that your friend is a better performer? ओनली बेसिस ऑन दिस नंबर ऑफ क्वेश्चंस पर आवर कैन यू से, क्या आप बता सकते हैं कि आपका दोस्त बहुत अच्छा है, इंटेलिजेंट है, स्मार्ट है और बहुत अच्छा काम कर रहा है? कांट से दैट why just because you were solving very complex problems and your friend was solving very easy problems, right? So here also it can happen. Let's assume. Now I am mapping the same thing. Let's assume that two processors we have, or two CPUs we are having. Two CPUs we are having. Suppose processor P1 and P2. Right? P1 is having MIPS count. P1 is having MIPS count 20 MIPS. So it can execute 20 million instructions per second, and P2 is having 10 million instructions per second. Can I say P1 is a better processor? Can I say P1 is a better processor? I can't. You know why? Just because it might possible. Just because it might possible that the type of instruction P1 is executing is very very complex. Type of instruction P1 is executing is very very complex. P2 is executing very easy, very very easy, simple instructions. In that case, this result may be a false result in the comparison, right? If you are understanding, if you are clear about this, you need to type down in the comment box. हर टाइम पे आपको जो भी clear होता है, you need to type down every single time that if it is clear or not clear, so that I can understand your learning. I want your learning, boss. I want your learning, and you need to tell me every time that you are learning or not. My motive is our family. Our family should reach to the IIT or should reach to the destination whichever you have decided. Somehow, my family, you are my family, our family should reach. So if any top 100 we will take next year, we should know कि ये top 100 हमारी family से, all 1 to 100. That is my target. That is my target for you guys. Fine. So if you are able to understand every single thing, let's go further. That MIPS may provide false result for comparison of two processors, and why it can provide, just because it does not. I'm writing further because it does not consider it does not consider complexity of instructions. कॉम्प्लेक्सिटी ऑफ इंस्ट्रक्शंस, विच मीन्स कि कौन सा इंस्ट्रक्शन कितना इजी या कॉम्प्लेक्स वर्क करेगा वो नहीं इंक्लूड किया है. विच इंस्ट्रक्शन विल परफॉर्म कॉम्प्लेक्स ऑपरेशन और इजी ऑपरेशन, दैट इज नॉट कंसिडर्ड इन MIPS. That is why this MIPS cannot give you a good result, true result. And to solve this particular problem, we are having another metric called as FLOPS. Let me write in the green: solution. So solution is flops. Flops consider the operation which is floating point operations per second. Floating point operations per second. So in 1 second, how many number of floating point operations a CPU can perform? That is the flops, and here I am calculating the operation in the, or I'm calculating the performance in the terms of complexity. How complex operation can be? Floating point operation can be very, very complex. So in that case, I am considering the operation. Hence, this particular false problem will not occur with flops. Chali. So here I'm solving a question for you. GATE 2014. This question is okay. If you can try along with me, that's perfect. If not, then I will anyway solve for you this particular question. Such kind of questions may help you to understand कि whatever you have learned till now, these formulas and these understandings, how you relate all these understandings to solve the problem. And that is the major thing, that is the biggest thing required for GATE preparation. If you are preparing for GATE, if you are clear about the topic, that is one part of preparation done. Other part of preparation, which is the major part of preparation, is how you use your understanding to solve the problem. That you need to learn, and that is different thing which nobody can teach you by just teaching you. If I'm teaching you, you are learning, you will learn definitely each and every concept. But how to attempt the question, how to understand the question, how to solve the question, that is the problem solving, and that comes with very different kind of approaches, very different kind of teaching, very different kind of explanation. So you need to be the part of such kind of revolution if you are really lacking in such kind of problem solving activity, which is major part. Why I'm saying कि knowledge बहुत लोगों को बहुत होता है, but maximum students will not get maximum number of marks because they were not able to solve the question in GATE exam. And why? Just because they were not able to understand कि ये solve करने के लिए use कौन सा knowledge करना है. We couldn't understand, we couldn't rectify, and that is the problem solving skills which you need to learn, which you need to improve. How you will improve? That is secret. I can help a little bit here, but I cannot help a lot just because we don't have very interactive study here. One thing, and second thing, for that we are having this platform Unacademy Plus. So if you really want to know how to do that and that and that's every single thing, of course, you can join using this code VDeep10. I'll be helping you to solve or to understand the problems, to understand that how to solve the problem using the given knowledge. Let's solve this question. Consider two processors P1 and P2 executing the same instruction set. What does it mean? Every single line you need to read, you need to understand every single phrase, you need to understand what is given. कैसे समझोगे? Until you won't have, if you are not having any knowledge, you can't. But if you have knowledge, then too you need to map it ना कि ये knowledge अच्छा वहाँ पे map करता है. Fine. So let's try to decode this particular question like this way, that if two processors P1 and P2 you are having, these two processors are executing same instruction set, which means type of instruction P1 supports exactly same supported by P2 also. Type of instruction P1 is having all the same instruction numbers also, type also, everything is same to same in CPU number 2. If addition instruction is like this in P1, same to same in P2. If there is an instruction move in P1, then in the P2 also same. So same number of instructions supported by processor and same type, exactly same type. एक जैसे इंस्ट्रक्शन दोनों में रहेंगे. So these instructions are not program instructions. These are the instruction which a processor can support, right? So same instruction set means same type instruction supported. Same type instructions supported. Fine. Now assume that under identical conditions means same to same conditions for the same input. अब ये different चीज है. See, same input means now you are talking about program के instruction. पहले आपने बात की थी कि किस टाइप के इंस्ट्रक्शन, किस टाइप के इंस्ट्रक्शन प्रोसेसर P1 कैन अंडरस्टैंड, व्हाट टाइप ऑफ इंस्ट्रक्शन P2 कैन अंडरस्टैंड, बोथ आर सेम टू सेम. कि P2 can understand these instructions, P2 also can, P1 can understand these instructions. अब बात कर रहे हो कि आपने अगर एक प्रोग्राम चलाया, उस प्रोग्राम में क्या instructions है, in that program what instructions are there, and that program those instructions are also same to same. So for the same input means, for the same input means program is same, which means in the program, if on P1 execution or on P1 processor, if you are having 100 number of instructions, तो P2 पे भी कितने number of instruction execute करोगे प्रोग्राम के? 100. Why? क्योंकि ये same instruction set है इसलिए, क्योंकि just because same instruction set is given. Right? So same input means program is also same. I can say number of instructions are equal. Number of instructions are equal in both the processes which we executed. So we have executed some n number of instructions in P1 processor, same number of instructions we have executed in P2 also. Now, a program running on P2 takes 25% less time, 25% कम टाइम लगता है, क्यों? Because of internal working, जो भी CPU का डिजाइन है उसके अकॉर्डिंग. So 25% less time but incurs 20% more CPI. साइकिल्स पर इंस्ट्रक्शन ज्यादा है बट टाइम कम है. हर एक इंस्ट्रक्शन को एग्जीक्यूट करने के लिए जो टाइम है या टोटल टाइम जो दे रखा है वो 25% कम है. वो 25% इसलिए कम है क्योंकि सीपीयू फास्ट हो सकता है, बट साइकिल्स, नंबर ऑफ साइकिल्स आर मोर, 20% मोर नंबर ऑफ साइकिल्स आर रिक्वायर्ड एज कंपेयर टू द प्रोग्राम रनिंग ऑन P1. चलो कंपैरेटिव स्टडी करते हैं यहाँ पे. Comparatively, I am writing P1 processor here, P2 processor here, and if I am talking about number of instructions, you only tell me how many number of instructions in P1? Number of instructions executed in P1 is equal to suppose N1, and in P2 it is N2, and we know that N1 is equal to N2. दोनों number of instructions बराबर बराबर. Right? Now, second thing is execution time. Suppose execution time of a program with n number of instructions is T1 here and it is T2 here. They have given a relation. What relation is कि ये P2 जो है वो 25% less time ले रहा है, 25% less than T1, which means I can write T2 is equal to 0.75 of T1. If you are agree with me, okay fine. If not, then you need to type down कि क्या समझ में नहीं आया. 25% less means whatever the time T1 has taken, that 0.75 of that T1. And then what is the CPI? CPI, if suppose CPI for processor P1 is C1 and CPI for processors P2 is C2, then CPI what they told, 20% more, ज़्यादा है. So 20% more of C1 means 1.2 of C1 in the fraction. I guess you can understand these two things very easily. You are the mathematics person, you are the mathematics guy. So if you are fine with this, then what they asked is, if clock frequency of P1 is 1 gigahertz, so frequency is nothing but clock rate. Okay, frequency is nothing but what? Clock rate of the P1 processor is 1 gigahertz. So suppose F1 is given as 1 gigahertz. I don't know what is F2 that we asked for. Now you need to revolve under your head and you need to check down that particular memory, that particular knowledge where you have relation in the number of instructions, execution time, CPI and the clock rate. Let's go back. क्या हमारे पास ऐसा कोई फॉर्मूला है? हाँ जी है. Here this particular thing you can write down like this way also, that execution time for n number of instruction is equal to number of instructions n into CPI average into one cycle time. Instead of one cycle time, what you can write is divide by clock rate. Can you write this? Can you change this particular formula? This execution time for n number of instruction is equal to n number of instruction into CPI average divided by clock rate. Can you write this? Of course I can write this. If I can write this, this is the formula. This is the formula I am having relation with number of instructions, CPU execution time, CPI and clock rate. Let's use it. Let us use it. So I am having the formula like this, that execution time is equal to n number of instructions into CPI divided by clock rate. Can you calculate the value of n from here? What is the number of instructions from here, which is execution time into clock rate divided by CPI? If I am equating these two, N1 is equal to N2, number of instruction for P1 processor and P2 processor are equal, can I write this, that time required T1 into clock rate frequency F1 divided by CPI average C1 is equal to T2 into F2 divided by C2. अब तो सिंपल हो गया यार, वैल्यू रखो आंसर लाओ, वैल्यू रखो आंसर पाओ, प्रतियोगिता हो गई अब तो, आगे बढ़ेंगे। चलो T1 is value same to same, frequency 1 given as 1 gigahertz, C1 is as it is, T2 value, what is T2 value in terms of T1? 0.75 of T1 into F2, I don't know, I'll have to calculate, divide by C2 is what, 1.2 of C1, use this, so C1 से C1 तो कैंसिल हो गया, ठीक है, T1 से T1 कैंसिल हो गया सर, F2 की वैल्यू क्या होगी, F2 is equal to, answer is 1.2 divided by 0.75 into 1 gigahertz, which is equal to 1.6 gigahertz. So the answer for this particular question is 1.6 in the gigahertz. That's how you are going to solve such question. Very simple it is. Yes जी, वहाँ बहुत simple था 2014 के question. If you understand every single phrase, every single statement, question is very easy. This particular formula, so you can easily calculate on the runtime also. You don't have to remember it anymore. Fine. One last thing before we compute or before we conclude today's session is ALU. Let me finish this and we will go for our work. Means we will wrap up this particular session. So what is ALU? Of course you know ALU is what, right? ALU is what? ALU performs the operation, arithmetic and logical unit. मैं आलू बोलता हूँ उसको. ALU is the unit which performs the arithmetic and logic unit. What exactly I want to tell you is this in the ALU. Very small topic, very small information I want to give you. This particular ALU you can design or you can denote like this way. Look at this. In the ALU, you take two inputs for the operation, right? These are the two input operands. These are the two input operands. If you have attended my previous lectures from starting, I have given some input, some detail of this particular ALU before. If two input operands are there, on these two input operands, ALU performs the operation and then it generates the result. And at the same time, it generates the status of the result also, that is stored in the status register. So status also generated by your ALU about the result status, right? So what is that status? If input this particular result is 0 or not, this result is having sign plus or minus, this result is having a carry or not, all these status will be stored here in the status register. But one more thing I want to tell you here is this ALU is capable to perform so many operations. Within the ALU, over these inputs, two inputs, ALU can perform addition also, subtraction also, and XOR, or, right, XNOR, subtraction, division, multiplication, multiple operations are there which ALU can perform over these two inputs. Now, what operation to be performed at that moment, at that particular time, which operation to be performed over this input, that will be decided by some control signals coming from control unit. So control unit generates some kind of control signals for this ALU, and these signals we call as function code. And why these function codes are used? These function codes are used so that my control unit can perform or can inform to ALU कि भाई ये addition करना है इन दो input पे, कि भाई ये subtraction करना है इन दो input पे. So which operation to be performed over these two inputs, that will be decided by this function code. So every ALU takes two types of inputs. One is function code, one is operands. Two types of outputs it generates. One is result, another one is status. Remember this particular point and you will not you will be able to understand further few points. Tomorrow I am going to explain you data path. Data path is what, based on that data path diagram, you will be able to understand what is a micro operation, how it is performed by CPU, how CPU works, and how control unit works. Everything you will understand tomorrow using that particular data path diagram. So tomorrow again we will meet with the data path. This is the batch I am talking about. I was talking about on the YouTube. My entire team is working. See, Pankaj Mishra sir is there, Malesham sir is there, my class is there, Satish Yadav sir is there. This is the discrete math topic you are going to have 7:30 onwards in the same channel. Subscribe the channel so that you can get all the details, all the notifications about the class. And you need to do what? You need to like this video, you need to share this particular video, share the channel with all of your friends who are preparing for it with another topic. Okay, don't forget to like and subscribe the channel. And happy learning. खूब सारा सीखो, सीखते रहो, खुश रहो, enjoy करो, and achieve whatever you want to in your life. See you.